Integration by parts. Let's use it to integrate sec cubed x. Okay? Now guys, when you do integration by parts, you might have heard about this I latte rule or something. I do not like that because it doesn't always work. Don't stick to these silly rules because there's so many examples I can give you where I latte doesn't make any sense. L meaning log, then the T meaning trig, E meaning exponential. Try that with e to the power of x sine x. Doesn't work, mate. So, guys, it's all about experience. Integration is all about experience, all right? I can say that again and again. So integration by parts is looking, very similar to the product rule, because we can derive the formula for integration by parts from the product rule, is looking at the multiplication of two functions, okay? So if we want to use that to integrate sec cubed x, we have to rewrite it as a multiplication. Well, the natural thing to do then is to write as sec x times sec squared. And then we're going to go straight into parts. Now, if you know me well enough, you will know that I teach Liddy. The form is always the same. Now, the most important bracket in integration by parts is the d, the differential of something. So, leave, integrate, sec squared integrates to tan because we're thinking about what differentiates to sec squared is tan. Then differentiate the first term, sec differentiates to sec tan. Then remember these two brackets always the same. Okay? So what are we left with? We're left with sec x tan x minus the integral of sec x tan squared. Okay? That's a bit of a weird one. I mean, how do we integrate something like this? Could we potentially use a guess? Maybe. I mean, it kind of looks like a power function, okay? But if you were to write this as tan x all squared, tan x does not differentiate to sec, does it? And if you were to treat sec as maybe the angle here, and you add 1 to that power, sec does not differentiate to any kind of tan squared, okay? So, it's not looking good there. How do we integrate this then? We probably need to use some trig identities. I know tan squared is sec squared minus 1. I had to remember that one. So I have 1 plus tan squared x is sec squared x. So if you're ever stuck, you know, it makes sense to just convert everything to one function. Maybe it will give some vibes of what we need to do. So we're going to minus 1. Okay? So overall, it has become sec x tan x minus the integral of sec x, and then we get sec squared x minus 1 dx. Let's expand that. Sec x tan x minus the integral of sec cubed x minus sec x. Interesting. That's what we wanted to integrate at the beginning. This is known as a cyclic integral. It goes round and round in circles. Big up Mac Miller. This is equal to this. So from there, we can just do a bit of rearranging here. But what we need to do is we just need to split this integral up and do a bit of movement. So I'm going to say the integral of sec cubed x dx is equal to sec x tan x. And then we can split this integral and say it's minus sec cubed x dx minus the integral of sec cubed x dx. Then the double minus becomes plus the integral of sec x dx. Okay? That can come to this side, and we'll have two of them. So we have 2 integral sec cubed x dx is sec x tan x plus the integral of sec x dx. Now, this is a standard integral. It's a recip function. It's going to be ln. Now, the easiest way to remember what sec x integrates to in terms of ln is you just need to remember what it differentiates to. Now, we already know what sec x differentiates to because we did it earlier. But It doesn't integrate to ln sec x tan x, it's ln sec x plus tan x. Ln sec x plus tan x. Okay? And then we're going to get our answer because we're just going to half both sides. So therefore, the integral of sec cubed x dx is a half of sec x tan x plus ln sec x plus tan x. And then we get a plus c. And that is our answer for the integral of sec cubed. Now this would be regarded as a tough question. If you guys want to keep practicing cyclic integrals, then integrate e to the power of x sine x, e to the power of x cos x. They will all be cyclic integrals. Those ones you actually have to integrate twice before you then rearrange. So I recommend you guys have a go. But if you learned something new today, guys, I'd really appreciate if you hit the like button, subscribe for more maths content, and if you're interested in my A-level maths courses, more details are in the description. And feel free to join the Learn Gang community on Reddit if you want to submit your own questions and get feedback. Link is in the description. I'll see you in the next video. Nice.